Hello, Mario! In this video we're going to be calculating a resection, a classic surveyor's problem from days gone by, sometimes referred to as the 3-point problem. In days before EDM, when measurement was difficult, you could set up at any point, at a random point, and observe to 3 or more known trig stations, usually on high hills. Back in the office with your trusty oddner or log tables, you could then calculate your position and get an origin. And this was the start of many surveys where origins were hard to come by. But these days, of course, with EDM and things, we don't use the resection so much, although we do use a variant of it called the free station. So anyway, here we are just with a simple resection of 3 stations, and I'll talk about that a little bit later on. So here we are, we've set up at Q, we've observed A, B and C known stations, and here's our values. We've got a direction of 0 to B, 114, 56, 15 to C, and 260, 02, 50 to A. So first thing to do is to get out, see what information we can find out. So here we are, we can calculate C to A to B, B to C, just missing line on total coordinates. You can see some of my videos on earlier videos on my video channel of how to do that if you wish, using my trusty HP15C. So once we've got our bearings A, B, B, C and C, A, we can now work out the various angles, and I've worked out the angle at A from my bearings, A, B and C, and having worked out those angles, obviously we're surveyors, so we've got a check on what we do. We add them up, they add to 180, things are pretty good there, okay to move on. Next thing we want to do is look at the internal angles. So here we go, 0 round to 114, 56, 15, that's pretty easy. And then from 114 round to 260, 05, which gives us a bearing of 145, 05, 50. An angle 145, 05, 50, and then we move from there round to 360, 360, 00, 260, 02, 05 is 99, 57, 55, which we've calculated there, taking it away from 360. Let's just check that our angles 114, 56 add to 360 degrees. So yep, once again we got a good check on those angles, and we can move ahead with some confidence. So let's go to the next step. Now the next step in this situation here involves what we call a formula, or the method, and it's called the Teenstra method of formula for working this out, and it relies on a very sort of precise way, or you've got to be very careful as to how you label a triangle. So it's labeling the triangle A, B and C refers to these outside angles here that we've calculated, and then our internal angles. So we have alpha opposite A, so in this position here, so A's there, alpha's opposite, B, beta is opposite. So just very important that you get these angles labelled correctly in the correct relationship to the other one, and similarly gamma opposite C. So that's in there, that's how they are. So it's very, very important that they are right. And here we are, we have our formula here, use the formula, and we've got this K1 times northing A, K2 times northing B, K3, and over K1 plus K2 plus K3. Now these K1 is equal to cotangent A minus cotangent alpha. 1 over K1 is equal to that, 1 over K2 is equal to that. So it follows a very familiar, very simple pattern, and 1 over K3 is that. So how are we going to deal with that? It's quite tricky. So I had a good look at this, and I think I can do this with a bit of a spreadsheet might be the go here. So that's what I did. I opened up my Excel and I had started out with a spreadsheet, and here's my spreadsheet here. What I did was down here I put it in individually in the degrees, minutes and seconds in individual columns as individual values, A, B and C for the various for those A, B and C, and for alpha, beta and gamma. So I've put them all in there. Now the thing with Excel is that it works in radians. It doesn't work. So what I then did was converted all of these angles to radians. Now obviously a circle 360 degrees is 2 pi radians, so we've got 72 degrees 0 minutes 41 over 360 times 2 pi gives us the radians. So I could put a formula in there, copy it down there, and we've worked out all the radians for all of the angles there. And then having got those radians, we then needed to work out the cotangent, what the cotangent was of each of the values there, so that then we could work out the k values from the Teenstra formula, where k1 equals or 1 over k1, and we were able to work out k1 here from the formula, k1, k2 and k3, and then putting our northings of A, northing of B, northing of C, and so putting that all in order and working it out, working through the familiar pattern of the Teenstra formula, which I showed you on the previous sheet there. We were able to come to these coordinates here, 7884.577 and 3078.081. It would have been very helpful if I had repeated the formula here, but unfortunately I haven't. So however, you should be able to get copies of my notes by just emailing to me, or perhaps you could maybe take a screenshot of the previous one with the formula in it, so that my little resection spreadsheet here comes well. And this works out very well. Now I created the Excel spreadsheet. Note, the Excel works in radians. I've told you that already, so I'm telling you again now. Now the order of the angle and the relationships is critical for the correct solution, as I explained with the earlier slide. So alpha is opposite A, beta is opposite B, and gamma opposite C. Now, just by way of looking at resections here, a single resection calculation like this has no check. We're very much reliant on observing and getting the right values. So quite often we do more. So how do we deal with more resections? Well, if we've got 4 stations, there's more combinations that we can work with. So what we do is, just using simple combination type things, we work out a resection for each of the possible combinations, which will give us a value of Q, and then we take a mean of that. But before we do that, we look very carefully to make sure that they're all in reasonable agreement. So with A, B, C and D, you can have A, B and D, A, C and D. I think there's 3 or 6 different combinations that are possible. So yeah, and that's a very good check. So where there's more stations, you take the mean coordinate values of all the possible combinations of the 3 stations, and that way there, and you're getting a check on each one then. So just a single resection like this, as I say, is very dangerous animal, because there's no check. And so there you have it, the classic resection or 3-point problem.